This conference will now be recorded.
So, thanks, folks. I hope you can hear me just fine now. And I apologize. We, of course, tested everything, and you still are going to have anomalies. It's kind of what I wanted to talk about today with PON testing. So I know a lot of folks that have joined have PON networks, obviously, and you're probably interested in ways of testing. I want to talk about that and kind of break it down into a couple different phases. And that's something I've noticed talking with a lot of customers is everyone has a different deployment plan or rollout. And I thought I wanted to kind of discuss that in terms of the different phases of construction and maybe get some feedback from some of you guys. I see Michael and Aaron and Ryan and everyone's chimed in on the chat, so please keep that coming. But let's first take a look at this little network map here. And this is a great poster that we'll be sending out from Expo that kind of describes a standard PON network. We're looking at the CO environment down here. You know, you have your OLT. If you have an optical video transmitter or an RF layer, that would be coupled in. Of course, in this scenario, we have an XGS PON OLT. This could be obviously a regular GPON OLT, patch panel, then out to a fiber distribution hut or some sort of fiber distribution area. And I have seen this condensed into the CO as a network architecture, and that works fine, but it does basically, we just want to talk about it as a test point. And then from our fiber distribution out to drop terminals, depending on the topology of the network, it could be a star topology or more of a line topology. But from your network terminal, or from the drop terminal rather, you have drops going out to the various ONTs. And so each one of these locations, drop terminal, customer ONT, and fiber distribution hut, and actually at the CO, these are all potential test locations. And you can see here that Expo's done a great job of kind of identifying the areas where we can test these portions of the network. We do an optical loss, bidirectional optical loss testing from the CO out to the drop terminal. And then also we could do that same testing from the drop terminal out to the customer ONT, but it doesn't really give us a whole lot of extra information. And realistically, with any sort of testing, especially PON testing, that's what we're looking for, is additional information. So even here at the customer ONT, we can use a standard power meter or even an OX1, which we'll talk about briefly, which has a power checker mode, or even one of these small power checkers like the MPC 103. Now, all of these power meters are limited in their capability in that they do not have a filter in them. And we'll also talk about a PON power meter, which is a filtered power meter. If you have a single wavelength coming down from the CO or out to your customer, 1490 typically for GPON, you can check the level, the power level at the customer's prim with a simple power meter, a PX1. I've got an MPC here, and that's going to give you, basically tell you whether or not the ONT has enough light to operate within its parameters. Of course, the amount of light that shows up at the ONT is dependent on a lot of different variables, the drop cable being installed correctly, the drop terminal being built and installed correctly, and then having signal all the way through the splitter and out to the ONT. We can use a power meter or to kind of confirm that information. But if we don't have any light or sufficient light, the power meter doesn't really give us the tools to gain additional information. The next step up from that, or what we'd look at, would be a PON power meter. And a PON power meter is unique from a standard power meter in that it includes some filtering to segregate out specific wavelengths. And one of the aspects of this little poster here that I really like is that it does go into all of the next gen and legacy and current wavelengths. So down here at the lower right of the poster, like I said, Ashley will be sending this out to everyone. I think everyone's typically accustomed to the GPON. Our PON rate, 2.5 gig down and 1.25 gig up. The downstream wavelength is 1490, and then our upstream wavelength is 1310. If you were probably a cable operator that's moved over to fiber, there's a good potential that you would have an additional RF layer that you'd be transmitting out at 1550. So you'd actually have 2 downstream wavelengths in that scenario. And that's where it becomes really important that you have a filtered power meter, because you will not be able to distinguish between 1490 and 1550. A standard power meter will just see an aggregate of both of those wavelengths, and you'll get some strange readings, positive numbers and that sort of thing. The next generation of PON that most of the customers I've discussed that are looking at are either XGS PON or potentially even NG PON, but I think we'll see a wide adoption of XGS PON earlier. Interestingly enough, the downstream central wavelength is something that's we're not as accustomed to seeing, 1577, and then of course the upstream is at 1270. So with XGS PON and NG PON and any of the other next generation technologies, we're going to need to be able to filter and look at specifically those wavelengths, especially if we have 2 wavelengths riding on the same fiber. So we already have a GPON system in place, and then we're going to be adding an XGS wavelength on top of that. That's where it becomes really crucial to have that PON power meter. And our PPM 350D with the PON aware technology is actually very handy, so that it allows you to, or it will automatically tell you which wavelengths it sees on the link when it's connected in through mode. We'll talk about that in a little bit more detail here. The other area, or the other concern or area of testing that I hear a lot of, excuse me, let's see if I can make this a little bigger, is when we don't have enough light. So we get a PON power meter, we connect it in line, we see light coming from the CO, and maybe we don't see anything coming from the ONT, or conversely, we don't have any light coming from the CO. So we've got to identify where the issue is, either upstream at our drop terminal, or at the fiber distribution hut, or even as far back as past the splitter. Now, there's some questions or a decision tree that I always discuss with PON testing that makes it pretty simple. In this scenario, we can see I have 2 customers coming off of this we'll say a 1x4 splitter. And if both of those customers are operating, or rather, if both of those customers are have an outage, then we can make some determination of that. Maybe the situation or the anomaly that we're looking for is between the CO and the splitter. If one of the customers is not operational and the other customers on that splitter, then there's a good chance that it's the link between the customer and the splitter. So that's a pretty basic decision tree. Is it one customer out or multiple customers out? And at that point, we know whether we're going to be testing between the splitter and the customer prem, or actually looking at the splitter. There's lower likelihood, but it's possible that the splitter could have some damage or need to be replaced. But also more importantly is the cable that comes into the splitter. And so that kind of also brings me to kind of the phases of construction and where, or the phases of your deployment and where you're going to be testing. A lot of, and that kind of brings us to the next piece of equipment is our OTDR. And a lot of folks who have an OTDR are able to use that OTDR to troubleshoot, obviously, any portion of their network. However, it gets to be a little bit of overkill for the fiber to the home and doing the drop links, and that's where we have, or Expo has developed the OX1. And that's kind of slots in between the power meter and the OTDR. It's not a full-blown OTDR. I'm not able to pull down any trace files and save those for records on the network, but I am able to use it to troubleshoot any issues in the link and actually qualify that fiber link based on the criteria that I give the OX1. So When we are doing the initial installation, and this is something I've seen where we'll have all of the backbone fiber installed to the splitter and splitter cabinet and tested to that point, and maybe even out to the drop terminals, where all the splicing is done by one crew or one side of the house. And this obviously depends on the size of your organization and how many technicians you have. But what seems to be a typical rollout is the fiber installed all the way to the drop terminal and tested there. You can obviously connect that to the OLT and just test with a power meter to confirm that you have light at all of the ports coming out of the splitter. But what I would suggest, and I think is a better use of the equipment that may be available to you, is to test the entire length from the CO to the splitter. Make sure that that link is sufficient, and then test from the splitter out to the drop with your OTDR. You can, of course, test through the splitter, but as we're going to look at here in a moment, you don't get a whole lot of information other than just verifying the loss of the splitter. And if that's something that you want to confirm, then you can, with the OTDR with enough dynamic range, you can test through that splitter all the way out to your drop terminal. But it's actually probably give you more information when you're testing from the prem towards the CO. And that's just based on kind of how the physics of the splitter works. We come to the splitter and we send light out to the splitter. We see the reflection and the loss of the splitter, but beyond that splitter, we could have different lengths of fiber. So if we're testing in the direction from CO to the prem, we're going to see a really odd OTDR trace when we have different lengths of fiber, because we're going to see reflections at different times. So that's, definitely I get questions on, well, can this OTDR test through the splitter or multiple splitters? And if you have enough dynamic range, you definitely can. But my question is always, what additional information does that give you? If you're just looking to verify the loss of the splitter, that makes sense. But if you're looking at whether you can meet your entire loss budget, I would suggest that using a power meter or an optical loss test set to verify that loss budget is going to be more effective than the OTDR. The OTDR is going to give you a better summary of all of the events and the insertion loss and optical return loss on that link. So, and that may or may not be beneficial for shooting through a splitter. I would definitely suggest, and what I wanted to demonstrate for you guys, is the difference between how an OTDR operates, the OTDR software, and then the IOLM software, especially in a PON environment. And then also we'll take a look at the OX1 and some of the use cases there. So let me swap over. There we go. So, pardon me. So I've got my Max tester here, which is shut down on me while I'm chatting with you guys. And just so I want to make sure that you're able to see all of the software, we've got a remote session here in the upper right-hand corner. You can see the screen here. What you don't see in the background is I've got a little PON test environment that we're going to be shooting through. And in this first scenario, I have I'm shooting from the customer prem back towards the CO, and I have actually two splitters, a 1x8 splitter followed up by another 1x8 splitter. And this is all going through a single fiber, and then once I get through both splitters, it splits out into two optical circuits, one with a 10 meters of fiber, and then one that has a couple splices in it that we'll take a look at. So first thing I want to do is actually open up my OTDR software, because I want to take a look at this. And if there's any questions as I'm going along, please feel free to stop me. I'll try and keep a look at the chat box here. So when we start out with our OTDR testing, I always make sure that we are looking at the correct test configuration. I have my link definition up. Also, my detection thresholds for splitter loss if I'm going to be shooting through splitters. I also want to have the macro band wavelengths. That's something we always want to take a look at. And you can also set up your pass-fail thresholds. Since my splitter loss is a little bit greater than 4.5 dB, I'm not going to do a pass-fail on that specific element, but I do want to set up a pass-fail for all of my splice loss and connector loss and the reflectance for each of those. So I've got my pass-fail threshold set up. This is also where you can adjust your IOR if it's a part of your test spec. I've seen a number of new test specs from various customers that are confirming that we set the IOR correctly for the fiber. So it's something to be aware of if you're using a Max Series tester. Once I've got the test configuration completed, I can start in auto. The auto mode, I like to remind folks, is always a discovery mode. It's not necessarily a one-button pass-fail. When we're using the OTDR software, we got to remember that we're actually trying to acquire information from the unit rather than having the unit give us, or the software give us the information. Depending on how complex our network is, we may be able to get the information we need with a single test shot, or we can, let's see here, in auto mode, we'll see what it gives me. Or we may need to do multiple shots, like a short pulse width for the beginning portion of the network, and then possibly even a longer pulse width later on. So just looking at the OTDR, I can see my launch up here at the beginning.
Hey, Eric.
Then go ahead.
Real quick, we had a question come in. Is this 32-way split or 64?
These are actually 1x8 followed by another 1x8. And I actually have another test environment that will do a 1x32 split. And now when we get up to that, we're obviously looking at pretty large losses. Does that help? I think that answers your question, Tony. The thing that I wanted to point out with the OTDR here is even in auto mode, which is what I see a lot of customers, I do see from the launch cable out roughly to the first splice, which it does have a, I would consider it a fail. It's got a loss of a 1.152, which is about in line with what my PON environment tells me it should be. No reflection on this, so I can tell that it is a splice, or I can make the assumption that it's a splice. And then I have another about 1,800 meters in this case before I hit my splitter. Now, I know that this OTDR has enough dynamic range to get through the splitter, but because I've got 100 meters past it and then another splitter, I may be seeing enough reflection that in the auto mode, at least, it's not getting all the way through. So what I like to do, or one thing you can take a look at, is starting up the real-time mode, and then you can auto adjust your range and pulse width, especially if you're looking at events that are unknown. There we go. So if I want to bump my range out a little bit and then go from a shorter pulse width up to a little bit longer pulse width, now I can start to separate out these events. I see that splice, I see that first splitter, and I'm in the pretty long dead zone until I hit that second splitter, in which case I'm going to have to even use a larger pulse width to really separate it out. And there's a lot of reflection back from that. So it can get a little bit confusing with the OTDR if you're not used to evaluating traces with splitters. You're going to see this and think, man, that's really unusual. Here's a big loss of about 10 dB, and then really only 100 meters to another large loss with a lot of reflection. And even with a larger pulse width, I'm still going to struggle to get my trace all the way out past there. Now, I I'm pointing this out on the OTDR software because I know that's what a lot of folks use. However, I do want to run this same test environment through IOLM and see what we get. So I'm just going to exit out of my OTDR, desktop, exit, and then I'll open up the IOLM software. I've actually went ahead this morning and calibrated out my launch, and I went ahead and put a receive cable on this as well, so we can take a look at the entire link and qualify that last connector there. So I'm going to use my launch fiber. Oh, looks like it didn't save my calibration, of course. So give me just 1 second. Go ahead and calibrate this guy out. There we go, 530 feet. And I know my receive fiber was 547, so I'm just going to go ahead and put that in. All right. Now that I'm connected, in my first connection on this side of the network is actually a UPC connection, so I can expect to see reflection on that, and neg 55 would be great. It'd probably be better than that. As the software is running, I always like to point out to folks that even though the IOLM software does take a little longer to acquire all of the information, it uses multiple wavelengths and multiple pulse widths to acquire that. So as I'm going through, you can see my 1550 wavelength or progress bar down in the lower right-hand corner. You'll actually see the trace start to change. So there's my launch cable. We've already identified that. We knew that there was a splice out there. And then we're looking at a splitter, and then 9,000 feet away, we've got another splitter, and we're going to run 1310 as well. So in the time that the IOLM is taking to complete the test, I could have my OTDR shot done. However, there we go. So at 4,000 feet, which is kind of to be expected, I've got a really high loss event here, and that's my first splitter. Then at 9,000 feet, I'm looking at I believe is a connector, and then we have a splice past it. Now this is, in the environment I'm shooting at, I'm going from a single fiber back through the splitter and then out to two different fiber lengths. You can see even here, I'm looking at a kind of a confusing trace because I've got two different legs that are reflecting back at different lengths. So I want to actually look at it as though I was shooting from the prim toward the CO. So I'm going to just switch my fibers around here just a moment, so that I'm swapping my receive and my launch cable. So I'm going to the other end of the fiber. I'll quickly scope this. All right, just to make sure that everything stayed nice and clean, I'm going to scope the fiber. That looks good before I connect it to my test port. All right. Going back into IOLM. Now I'm going to run the same test in the opposite direction, and we'll take a look at, actually, cancel out of that. I want to go up to my test configuration, and we're actually going to be looking at 2 PON splitters of unknown ratios, and that'll help us. Right, I'll go ahead and let this run really quickly. So just while that's running, I wanted to talk here. Basically, what I started out as is I was shooting from the CO through a single fiber out to a splitter, and then actually to another splitter, and then the 2 different separate legs. And looking in that direction, we get a lot of interesting information because we have different lengths of fiber that are reflecting back at different times. But if I go like I'm doing now, where I shoot from the prim towards the CO, I'm going back to a single fiber. So the reflection that's coming from the CO environment out to the premise is going to be from a single fiber. So it makes a little bit more sense as far as the reflections coming back. Now, of course, this is all going to be during the construction phase when we don't have any light on the fiber. Now, if you want to do this same type of testing during the deployment or after you have the OLT connected and you have light on it, then you're going to need some more specialized equipment, and that's going to be something in the realm of a live filtered port with a wavelength that's not going to be on the network that you're using. So on this particular unit, I have a 1625 filtered port, and if there were light on this the circuit, I would be able to shoot from the 1625 filtered port and not impact both the customers that are on the network on the other side of the splitter or anyone else. So, but that would be testing during the troubleshooting or after we've already deployed and connected customers. All right, so this is a little bit better trace or something that we can more easily look at. And it actually fits specifically or exactly with my PON simulator. So looks like my first connection has got some high loss right here at the splitter, so I need to check that one. There's my, or actually that's the connection to my unit. There's my launch cable. We do have a splice that it's about a half a dB of loss, which is at 1550, a little more than that at this point. That sounds about right. Our second splice also was supposed to be about a half a dB. It looks like it's a little bit better. And then our first splitter is a 1x8 splitter, and it has about 10 dB of loss, which is what was to be expected, no reflection. And then my second splitter, I've got roughly 10 dB of loss as well. And then out beyond that, we start to lose some of the resolution just because the losses are so high. So getting all the way out to or all the way to the CO at 11,000 feet. Although the footage is actually correct. It's just not seeing that last receive cable there. So we could take a look at it on the OTDR. However, I think we're going to see a similar trace as we did before, something that's kind of confusing here. And that's where the question I get often from customers is, will it shoot through splitters? Yes. On the OTDR, it's going to look very confusing to the uninitiated, especially if you don't know exactly the split ratios. But if you're utilizing IOLM and you at least give it the information that you're shooting through a PON network, you'll get much better results and more accurate results because we're using multiple pulse widths, and we'll be able to get them out of a single shot.
Hey, Eric, could you switch back to the overhead cam? You're on the PowerPoint slides.
Sorry, thank you. Yeah, there we go. Yeah, so that probably makes a lot more sense to you guys now. So there's our two splices, our 1x8 splitter followed by our second 1x8 splitter. And I said, just to kind of give you an idea, I'm just going to start up the OTDR and look at the same trace in the same direction. Running both wavelengths. Take it off of real time, and actually we'll run in real time and take a look at it before we do an average trace. Even bumping up my pulse width. There we go. Now I'm starting to see both of those events separate out. You've got to get up to a pretty large pulse width to really even see those events separate out. And at that point, I'm blowing past these splices early on. So we'll sit with about 50 nanoseconds, and I'll start a 30-second average trace. Give me a second here. So the purpose of what I'm trying to highlight here is that when you're testing a PON network, because of the splits and split ratios and the way that the light travels with an OTDR, you really need to make sure that you're looking at the full link with something that's going to give you all of the information. So that's where I think IOLM really comes into play. Also, you got to pay attention to the direction that you're testing in and understand how the splitters are going to split out and what you're going to be seeing. So if you're in the CO and if you're having an issue and you want to test past the splitter, understand that you're going to have some odd looking traces, and even IOLM could be confused by the multiple, depending on how many legs you have on there. So this is pretty good. Actually showing me my launch cable, the first link, and then now looks like this is that first splice, another 30 meters, and then another splice with some pretty high loss. That's about right. That looks good. Second splice is out, and then we start to hit our high loss splitters, and that's where things get a little bit squirrely, is past that second splice. So the best practice here would be then to look back and adjust my pulse width, maybe go a little bit larger pulse width, and then reshoot that trace. Now we can see that this is, after having to do multiple acquisitions, we really don't get a lot of the time savings of the OTDR that it seems to be on the surface. This larger pulse width seems to make things separate out quite a bit better. So that's kind of the OTDR PON testing, the differences between OTDR and IOLM. We recommend doing the OTDR for your initial construction phase and acquiring all of the initial documents to make sure that it looks like it's coming along. To record, what the condition of your network is before you start installing customers. And then, of course, you could do the same thing on the situation between the drop terminal and the customer, which if you're building out your initial construction phase just to the drop terminal, it's probably good to segment that portion out and have an OTDR or an IOLM shot for that. And then whoever's doing the customer drops, they may or may not be required to complete an OTDR shot, but it's probably a good idea to verify with a PON power meter that you're getting light from the drop terminal and from the ONT. unfortunately, my PPM 350D will probably arrive here as soon as this meeting is over. So I'm not able to utilize that. But if I was testing my PON network here, then I wouldn't be able to talk to you guys. So wouldn't be very effective anyhow. The other item that I wanted to discuss that we often talk about with PON testing is our OX1. And the OX1 is essentially it's the I like to call it IOLM light. It's not a full OTDR. It does use the same technology, but I'm not going to be able to actually pull any trace files, or other than a small report, I won't be able to get very many much in the way of I guess a trace file, anything more than a small report. You can see here that it gives me the length, the loss, and the optical return loss, which is all super important, obviously. But with the dynamic range of the smaller unit, I won't be able to shoot past a splitter. I can shoot to the splitter and characterize that splitter, and get a good idea of the loss there. Drew, looks like the question about is this a CWDM OTDR? This is actually, I'm only using 1310 and 1550 on this. For a CWDM OTDR, we're going to need something that will work in those bands on those specific wavelengths. The OTDRs are what we would call PON optimized, which it depends on the model. Obviously, this is a max 720 or 730 rather, and this is more of a kind of a metro and large area network PON optimized device. It has a little bit, I think about 39 dB of dynamic range, which that basically equates to, we're going to be able to shoot out to 60 miles or give or take, obviously depending on the network. So hope that answers your questions, Drew, on that. On the OX1, there's a couple different flavors of this thing. This version that I have in my hand has 1310 and 1550. It's going to work when there is no light on the fiber. So we're going to be able to, with both wavelengths, we'll be able to identify macro bends, obviously the length and the insertion loss and the optical return loss. And let's see here, I'm going to go ahead and kind of give you a quick demonstration of what I can do, or what the OX1 will do in the same test environment that we've already been looking at. Just disconnect this guy so I'm not shooting towards my OTDR. So just to really quickly, I'm just going to use my existing launch cable that I've got calibrated in here. It's about 165 meters roughly. Typically we could use as short as a 20-meter launch cable, but for the purposes here, I've already got everything connected, so I'm going to utilize this one. I have 3 different modes on the OX1. I have the flash advisor mode, which is a really quick, it's just going to give me a length and a loss and optical return loss, and it's going to rate the fiber. So if I'm at the customer prim in this scenario and I'm shooting out, let's see, make sure I've got everything connected. See what that I got the wrong. That's right. That's strange. Yeah, I must have. That's really odd to me. Excuse me, guys. Well, we'll try it from this other direction. Well, I must be using too long of a test cord length. Well, I apologize here. I must have done something when I originally set this up, but take a look at some of the measurements here to kind of give you an idea. I was shooting at earlier today, or yesterday rather. So with the flash advisor, as it would typically work, we can see as of yesterday, I've got a 1.25 kilometer fiber link with a good bit of loss here overall, and the optical return loss isn't that great either. You can see my first connector, what it would look like, higher loss than you would want. Our second connector, which is going to be at the customer prim itself, that qualifies and looks pretty good, loss and reflectance. And then this was actually looking at a macro bend at 966 meters, and then we got to our splitter, which was at about a kilometer away, and at that point we're going to not be able to get past it. So we're looking at essentially from the customer prim out to the CO. And let me see what we got going on here. So this type of, the OX1 with 2 wavelengths only is going to be for that initial construction phase. It is available with a single test wavelength at 1625, and that can be tested on live fiber, much the same as the 1625 filtered port on the OTDR. And then there is a newer version of the OX1 that has both 1550, 1310, and a 1625 live filtered port all in the same unit. It does come in at a considerably lower cost than the equivalent of an OTDR with the live filtered port, even though it does kick the price up of the combined unit up to kind of the range of what an OTDR would be with a standard 1310, 1550 wavelength.
This is Tony. I have a quick question. Is that
Sure.
So it sees both connectors on each end, but it won't go through the splitter. Is that correct?
Yeah. So the splitters have too much loss for the dynamic range of the handheld device, and it basically at that point it's just going to start seeing reflections. Even like a 1x1. Now we are able to do splitter detection and give you the loss if you identify the split ratio. So if I wanted to look at the 1/8, let's see if this guy will work for me. Does that make sense to you, Tony?
Yes.
And that's where, that's the limiting factor on the OX1, but it's not really intended as a device that's going to do that. And that's where I wanted to, highlight construction phase. If you want to go through splitters, if you want to see what the losses are, you're going to need an OTDR. If you're looking at troubleshooting and you're on this side of the network, then that's where the OX1 can come into play. And
yeah. Yeah, I was just going to say one's more of a field tool where the other one's more of a just verifying your network after construction and make sure everything's got continuity and in good shape.
Yep, absolutely. That's a good way to take a look at it. And the other big difference is that with my OTDR, whether I'm using the OTDR software or IOLM, either way I can pull those files down and keep a record of them during that initial phase, which, I mean, I've said that so many times, and I'm starting to see folks really take that and run with it, but I think it's pretty crucial, especially as we start to build more and more complex fiber networks. We need to make sure we have a good baseline of what is out there so that when there are problems, we can reference back to it. So if you don't have test equipment today, if you're looking at maybe just a power meter or something along those lines, and you're needing to verify that you have light, I think the first piece of, if you're looking at PON, we're probably an OTDR is going to be great for that construction phase, but once you're turned up, realistically, a PON power meter is going to be the best tool for just checking that you're meeting your loss budget. And then if you don't, you can utilize the OTDR for troubleshooting, or if you're working in the field, you can utilize an OX1. The real advantage to the OX1 is that it's handheld, so most of your technicians are going to have it with their other tools already.
Yeah, it makes sense. Sorry if you covered some of this at the very first, but thank you.
No worries. And that's, I kind of wanted to open it up for some questions as well. I wanted to see if there was any areas or questions that anyone had on, where we should test and when and how. The question that I think I wanted to kind of tackle the most is like, which direction do we test in, and what does it look like if we do? Because just by the how splitters work, but yeah, of course, lots of different scenarios. There's also, you can do some troubleshooting with just a basic power meter. However, you're going to spend a lot of time kind of chasing your tail unless you move up to something that's going to give you a location of the trouble. So any questions with anyone? Charlie, anything on your end?
Nothing else has come in at this point.
Well, that's pretty much what I wanted to cover. And if there's nothing else, and if there's no other questions, I'll let you guys have your rest of your day back. I want to apologize for the technical difficulties. The summary of this is we can test and test and test, and we still have issues. So I got to figure out a tester for my microphone.
Yeah, no worries. Thank you.
Thank you for everyone attendance. We will be having some more. If you have not received the invitations yet, we do have more scheduled, more presentations scheduled. The next one, if you're doing line power or need to test for ground resistance, a tool from Mager that will be presented, and that will be on the 24th. So if you've not received those invitations, feel free to reach out to us. Otherwise, please have a wonderful day.
You as well.
Thank you.